Hello everyone, we're talking about arrays today. Arrays are data structures that are multidimensional. So what's an array? Typically, we create a variable and the variable can store one value at a time. For example, over here, we create a variable called my staff to store the name of my staff member as a string variable. What that does is essentially creating a storage box labeled my staff, and I can store one name in there. So if I have a staff member name, I can put his name in quotation marks and store it in my staff. However, if I have another staff member called Nancy, if I want to store Nancy in this storage box, then Nancy has to replace name because I can only store one value at a time, which is sort of a hassle because if I grow my business, I may have multiple staff members and I do not want to have to create multiple variables to store my employee names. So what can I do? Well, I can create an array instead. Array is a variable with multiple compartments that are numbered. Here, I can dim my staff again, but this time using this notation, parentheses, 2 parentheses, to indicate that I'm asking for an array. So when you do that, VBA will create my staff with 3 compartments because VBA is a zero-based indexing language. We'll elaborate on that later, but basically it means that VBA counts from 0. So it'll create 0, 1, and 2. 2 is the upper bound that's indicated by your notation over here. That will become the biggest number in the index system. So by saying I want my staff, parentheses, 2 parentheses, I'm asking for 3 storage spaces in my staff. That way I can hire 3 employees and put 3 names in there. What I have created is called a one-dimensional array. My staff 2 creates 3 storage spaces, right? So my staff 0, my staff 1, my staff 2, they all kind of line up along a single dimension. So to recap, array is formally known as a type of data structure. It is used to store data, just like a variable. However, it allows you to store a bunch of data points and number them, right, using an index, a numeric index. All the elements of an array must be of the same data type, so you can't really mix and match string with integers or doubles in the same array. VBA is a zero-based indexing language, so counting from 0, that's the default. And that's why I labeled our week's assignments and quizzes all starting with 0 as a way to remind you that VBA is a zero-based language. We have seen how to declare an array, so here is just a sort of a review and to look at this more closely. This dim statement over here creates an array named my staff with 3 compartments, right? So 3 is the size of the array. We specify or ask for size 3 array by having the upper bound as 2 here. So when you do that, what VBA does is allocating memory space for my staff with 3 compartments, and we'll label them properly as 0, 1, and 2, and with 2 as the upper bound. Again, this is another jargon that you will have to remember what that means. So 2 is upper bound, 0 is the lower bound. The lower bound is what we call, zero-based indexing or one-based indexing. By default, VBA is a zero-based indexing system, which means we count from 0. So lower bound is by default 0. However, you can change the lower bound to 1 by using the option-based command. So option-based is a statement that you can have right below option explicit, which we often have at the beginning of a module. This statement will make the array one base indexing. So if you have the statement over here, option base 1, that's saying that for starting now, all the arrays that we declare will use the one base system. So when we do that, if we create my staff parenthesis 2 parenthesis after option base 1, then this my staff array will only get 2 spots instead of 3 spots. Okay, so 1 is the lower bound, and that's specified by option base, and the upper bound is 2, and that is specified by the array definition statement. Even if we start with option base 0, so you can have that statement in the very beginning of your code, we can override that decision by explicitly specifying the lower bound as 1 over here inside the parenthesis. So we can do 1 or 2. Okay, so that will override the decision of option base 1. But that overriding policy will only apply to my staff. So if you create another array without specifying the lower bound by default will still be 0 because we're still operating under the option base 0 policy. So 1 is the lower bound, 2 is the upper bound. Arrays work wonders with loops and cells. We have seen for loops before, and arrays just work very naturally with a for loop. So for a number from 0 to 2, we can actually store these into corresponding rows, right? So we're using zero-based indexing for the arrays, 0, 1, 2. However, our rows in an Excel worksheet is a one-based system, so counting from 1. So what we want to do is we want to add 1 to number before we use that for the sales command. And then we just kind of iterate through these going down from numbers from 0 to 1 or 2. We basically just go down the row to fill up the cells with my staff names. I can also create 2 dimensions for an array. So instead of my staff 2, I can now do something like my staff parenthesis 1, comma 4. This is the first dimension. This is the second dimension. Okay, so 1 is the upper bound for the first dimension. 4 is the upper bound for the second dimension. And that will look something like this. Okay, this is a 2-dimensional cubicle, and it's actually very similar to a 2-dimensional array. You have 0, 0 here, 0, 1, 0, 2, 0, 3, 0, 4. So you have 5 spaces in the first row. And then the second row is 1, 0. So this is actually not the most perfect analogy, right? VBA arrays do not allow you to mix and match data types, so you really shouldn't be storing people and printers in the same array, but you get the idea. 1, 1, 1, 2, 1, 3, 1, 4. So a total of 10 spaces. 2 times 5 give us 10 spots. The 2-dimensional arrays work wonders with nested loops. Okay, so here we have an outer for loop and an inner for loop. The outer one goes through numbers 0 to 4. The inner loop goes from 0 to 1 for the department. And that way we can iterate through all the elements of my staff. This is 0 to 1. This is 0 to 4. So we do a total of 2 times 5 or 10 laps. And that will give us this result, right? So we're printing my staff from department 0 This is department 0. So say, the account payable department, maybe this is the marketing department, and we go through employee 1, 2, 3, 4, 5, right? So for this department, they are printed in column 1, and my employees from the second department over here get printed into column 2 and row 5 using this nested structure. 2D arrays are just like a spreadsheet, or sometimes we call it a matrix, but basically it's rows and columns. When I dim my staff A10, that means I'm asking for 9 rows and 11 columns. Each of these spaces is indexed with 2 numbers. So we get the dimension 1 that has 9 spots, and then dimension 2 has 11 spots. So this gives us 2 dimensions. It gives us a 2D array. And the size of this 2D array is 8 plus 1 times 10 plus 1, or 9 times 11, or 99 spaces. So in a way, 2-dimensional arrays are not very different from the mailboxes that we see a lot in residential communities. So you can see that we might be able to create a bunch of storage, a 2D array storage space for the sales department, a 2D array for the cost department, a 2D array for the revenue department. And basically, if each department needs a 2D array, you will just dim 3 different 2D arrays. 3 or more dimensions are pretty rare in arrays. When you dim a 3-dimensional array, you can dim my cube 2, 2, 2, and that will actually looks like a Rubik's cube. Okay, so this will be a 2, 2, 2 kind of array, or a 3 times 3 times 3. And the indexing will look like this, right? So this is your first dimension going down, and then going across, we're going through the second dimension. So this number 1 here gives you an idea of the second dimension. Okay, so this is number 2 for the second dimension. And the third dimension will be going sort of the long way here. So 0, 0, 0, 0, 0, 1, 0, 0, 2. You can also create dynamic arrays, meaning that you can have an array with flexible sizing because you don't always know how many elements you will need. So what you can do is you can declare a dynamic array by not specifying the upper bound. So here, when I dim my staff, parenthesis, parenthesis without a number inside, that means I'm asking for an array of unknown size. So I'm asking VBA to be flexible. And I will specify the upper bound later, right? So what I can do is I can, here's an example, right? So I can use an input box to ask the user how many staff members do you have? And then I will store that answer into num staff, and then I can redim. So redim means that I redimension my array to this size, 1 to num staff. Okay, so that means that I redimension or resize my array dynamically, real time, in runtime. I can also add a space to it, so I can redim again to a new size, 1 to num staff plus 1. However, when you do that, when you redim an array that has been created, when you do that, you will actually wipe out all the data. My staff will become an empty array, has an extra space, but all the other existing spaces are wiped out. So you lose all the data. So this is sort of a very dangerous kind of command. You want to use it only if that's exactly what you want to do. Most of the time you want to preserve your data. So what you want to do is you want to say redim, but preserve my staff, 1 num staff plus 1. So you're resizing your array by adding an extra space, but the existing data points within the array will be preserved. You're not losing any existing data. You can also, because you generate the array size dynamically in real time, so you don't always know how big your array is. So you can always ask for the current size of the array by using the ubound for upper bound, ubound keyword to access the size of my staff. So here, message box, ubound my staff will just give us a message box telling us how big my staff is. And that's it about arrays. If you have any questions about arrays, feel free to email me or come to the office hours with your questions. Thank you.